from whatever it may be. Okay, this list of words at the top is a checklist for you to use. Okay, so you can look at them, circle them, highlight them, whatever you need to do. Those are the things that you should have in your answer. All right. So, the height of an object thrown straight up from ground is given by this equation, where t is the time in seconds after an object is thrown. So before I do anything, I'm going to figure out what the heck I'm talking about here. I like to sketch a little graph. This is not necessarily a pre-calculus thing. This is more of a Miss Ogden thing. This is how I approach a problem. So it says t is the time in seconds after an object is thrown, and h of t, based on its location and the way it says h of t, like f of x, I know that h is my y, and it is the height. Okay, please be sure that your paper looks like mine. I see a lot of people sitting and staring. Okay, now I'm going to go look at the function. The function is negative 16t squared plus 30t, etc., etc. So t squared is what type of graph? Okay, I know, yeah, nice. I know it's a parabola. I know it's a quadratic. The negative 16 means it's going to open down. So this graph is going to look something like this. Now, if you can't sketch the graph, that's fine. This is a calculator problem. Okay, but this is where we should be going with those parent functions. Okay, now, you guys just wait. I see people typing in their calculators. I'm not worried about you finding the answer in your calculator. I'm going to give you the answer. Okay, this isn't elaborate because you have to put words to it. So now it says find and interpret the average rate of change. Okay, from 1.25 to 1.75 seconds. So, average rate of change is the change in y over the change in x. Remember, it would be a slope if this were a line, but it's not a line. Okay, so I'm looking at the average rate of change. I know that the order that I put these in doesn't matter as long as it's the same in the numerator and the denominator. So I'm going to do f of 1.25 minus f of 1.75 over 1.25 minus 1.75. Okay, now, you now have three ways to plug this in your calculator. Okay, you can go plug in negative 16 times 1.25 squared, or you can define f of x as negative 16x squared plus 30x plus 4, or you can go back to your graph. So, what I'm going to do for this problem is I'm going to go to the graph. I'm going to open a new graph and I'm going to plug in my, you don't have to do this, you don't have to do it. Okay? This is review. So, if you go put this in, tab, new function, etc. Okay? I'm going to find my values by going menu, trace, graph trace. Some of you are still asking me how to do this and you need to write it down. Okay, because this is a review skill and we have covered it in this class a couple of times. So the first one, x that I want is 1.25. I'm just literally going to type it in and then the y value pops up at the bottom. So right now, based on what is on the screen, when x is 1.25, what is y? 16.5. So write that down where it goes in your equation. So when x is 1.25, y is 16.5. So what does that mean, you guys? It means right here, when I plug in 1.25, y is 16.5. Okay, we're about to do a rate of change problem in a minute where your calculator doesn't help you. So this is why I need you thinking about what these values mean, not just happily plugging away in your calculator. Now, what is y when x is 1.75? I can just type in 1.75, hit enter, and it will jump. What's y? 7.5. So at 1.75 seconds, the object is 7.5 feet in the air. Over 1 $1.25 minus $1.75 is negative 50 cents. Now, a lot of us freak out when we're dividing by decimals, okay, which is okay. But this is why you have your calculator if you need to, okay? If you're dividing by negative 1/2, 7 to 16 is 7, 8, 9, 10, 11, 12, 13, 14, 15, 9. So this is 9 divided by negative 1/2. So you can either multiply by the reciprocal, you can think it out, how many halves are in 9, right? There are 2 halves in every whole. Either way, 9 divided by 1/2 is 18. A positive divided by a negative is a negative. Now, here's the trick. That's all review. What we have to do now is we have to put words on it. So what the heck is a change in y over a change in x in this situation? So I'm going up here to this little bubble, just because I'm out of room. And I'm literally going to write down y in this situation was the height, x in this situation was time. Okay, well, I'm not going to say height per time or height over time. I'm going to use the measurements that they gave me. So what are we measuring height in? Feet. And what are we measuring time in? Seconds. So this is literally feet per second. Okay, that should ring to you from physics and everything else as velocity, right? Speed. But if it doesn't, just do this. Even if you don't understand what the heck you're writing. What are you writing? Kittens per year, right? Whatever it is. So my sentence is the same from 1.25 to 1.75 seconds, right? Now x has a label on it, so I'm no longer just saying x is this to x is this, okay? I'm no longer saying the function. I now have to say what the function represents, which is the height of the object, okay, is increasing or decreasing? Decreasing. Good. Decreasing at an average rate of 18 feet per second.